All right, I just kickstarted the recording. Good evening, everybody, once again, and welcome to another section in blockchain's UNNOG class. Today we're going to be continuing from where we stopped right on our series of building front-end user interfaces for your smart contracts. We're going to be having Joshua take the class. Joshua is a blockchain engineer working at Blockverse, and he's going to be the one to take us on the class. So please get your laptop, get stuff ready, and I think we can get started right now. So Joshua, I think I'll be leaving the floor for you.
All right. Good evening, everyone. So we're continuing from last week. Before we go in depth to what we have today, does anybody have any questions from maybe interaction with the library on their own and anything you need clarification on, or anything you discovered while interacting with the library after the last class? So can everyone hear me?
Yeah, I can hear you.
Yes, yes, go.
Okay, so I was asking if there are any questions or discoveries from the last time.
Yeah, can you hear me?
Yeah, I can hear you. Good
Okay,
morning.
it's not really a question, but it's just like an observation. I don't know from the ETA.js documentation. The code snippets they are like kind of like confusing to work. So I actually tried to implement what we did in the last class on my own using just documentation. I found myself going back to your code to look at what you did and try to figure out each line of code. It seemed like yours was actually much more easier to read and understand than the one from the docs. But maybe it's just me. So, but that's just my observation I like to point out.
Yeah, so I agree with you that the documentation, as it has JS documentation, can be a little bit confusing to go through. I think most of what they have is just trying to explain the basically the API for the library, and I think they are not so much example snippets that you could easily look at. I've noticed that too. So well, I'm going to try it as much as possible to simplify stuff. So even if you don't, maybe you find it confusing in the library or something, we could have like a clear understanding. So all right. So just give me 5 minutes. Let me set up on my laptop so I can share my screen and we can get started with what we have today.
Let me know the sense of brain. Okay. So today we'll be looking at interacting with smart contracts. We'll be going through the basics of basically working with a smart contract from ethers.js. We'll be looking at walking through deploying a smart contract with ethers.js up to calling smart contract functions. Wait. So a little recap on what we talked about in the last class. We mentioned APIs. We talked about providers, what a provider is in ethers.js. We mentioned what an API is and how it is useful for um, building our front end for a smart contract. Then we also mentioned what a provider is versus what a signer is in ethers.js. Then we mentioned what a contract is. So does everybody on the call get all these concepts, or do I need to go over them again? Okay. I think I'll take the silence as everybody gets it. So let's just move ahead. Though. So let's take a quick run at what smart contracts are. So I'm filming this from the last and previous interactions we've had with other instructors. Mentioned smart contracts, recent smart contract code. So smart contracts are like a self-executing code-based agreements that run on um, in our context, we're interested in smart contracts that run on Ethereum blockchain or on EVMs. So they're self-executing because they do not they do not need any intermediaries. So when you define maybe a set of rules or actions on a smart contract, for instance, all that needs to happen for the actions to be executed is for the conditions to be met, for any conditions tied to the actions to be met. And because of this nature of smart contracts, they are referred to as being autonomous and trustless because they are not controlled by an intermediary. Smart contracts are written in Solidity and executed by the EVM. So the EVM, the Ethereum virtual machine, is a runtime for smart contracts. So it's like when you have V8 being a runtime for JavaScript in the browser. So the EVM is a runtime for Solidity. So any blockchain that is EVM compatible can run Solidity. That's like the direct implication. Any EVM compatible chain can run any Solidity smart contract because the EVM is a runtime for smart contracts in Ethereum.
Smart contracts are deployed and stored on the Ethereum blockchain. Both the code, the data, any data the contract stores or interacts with, are stored on the blockchain, which is like a public ledger, which means you can trust the integrity in the sense that it is tamper proof. So because of the fact that any alteration, any alterations to maybe data on the blockchain can be traced and is publicly available on a ledger, you can rely on that fact for the integrity of whatever data the smart contract interacts with. Then smart contract interactions with smart contracts are initiated by transactions, like we mentioned in the last class, and transactions require a certain amount of gas to execute. And like we explained in the last class, gas is the incentive that is paid to the network for validating and executing a transaction. So a transaction can include interaction with your smart contract or what's it called, or sending Ethereum. But in the context of this session, we're concerned with interacting with smart contracts. Those are the kind of transactions we'll be looking at. Then smart contracts are immutable, they are transparent, they are self-enforcing, and they are very useful for building DeFi applications, building supply chain products, and building tokenization software. And once a con- for immutability, once the contract has been deployed, the code cannot be modified or changed, which means any set of agreements that has been defined in the contract before it was deployed cannot be modified in any way, with the exception to upgradable contracts, which is like not within the context of what we're discussing today. But by default, smart contracts are immutable. Then for transparency, like I explained earlier, the code and the data is publicly visible on the blockchain, which means anyone can verify anyone can verify anyone can verify what went to who and who did what. Of course, with decentralized identities. Like I explained earlier, the only condition for the only the only the only the only condition for contracts executing are the conditions that are predefined inside the smart contract. So it means there's no need for any intermediaries. That's why we can say smart contracts are self-enforcing. So for the use cases of smart contracts, does anybody know any maybe supply chain software that has been built using smart contracts or different applications? So can anybody on the call point us to real world use cases for the use cases that I mentioned here? That's DeFi, supply chain, and tokenization. If you can point us to any use case, just you can share the link shit. You can share the link. You can share the link in the chat box.
Sir, can you give us an example first, like an example of the use case?
Okay, so let me just let me open some applications that speak to each use case. So we can see. Let's see. So a good place to explore Web3 applications is um, is Alchemy Store, the Alchemy DApp Store. So Uniswap is a DEX, for instance, is a decentralized exchange, more like a decentralized version of Binance. There's actually a lot of them here. There's CoSwap, there's ZeroX for decentralized exchange and trading protocols. There's there's 1inch, there's MakerDAO, there's Compound. So there are actually a lot of them. So this is like for DeFi use cases. So let me send a link to the let me send a link to let me send a link to oh okay cool. Somebody shared an application, Instant Dab. Let's take a look at that. So for every of these applications that we mentioned, you'd observe that they actually require your a centralized identity, like a wallet, a crypto wallet, to function. So if I connect my wallet on Uniswap, for instance, I'll have access to the liquidity pools on the decentralized exchange. I can provide liquidity, and I can basically farm liquidity on and I can exchange. I can swap assets. I can swap assets. Okay. Then for tokenization use case, let's see. Tabs, reward assets tabs. Oh. So tokenization tabs will mostly fall under tabs are reward asset tab. So let's just check this out. Oh, okay, private credit. Let's see. Yeah. So this is this is an asset manager. Is it? Yeah. It's an asset manager. Anyways, tokenization use cases will mostly be building like tokenizing real world assets with blockchain technology, where you have like you can create shares that represent maybe like real estate, for instance, or a startup shares, and owning a percentage of owning some tokens also means like owning shares in the real world assets. So then for supply chain, well, I don't know how popular this use case is, but enterprises mostly use this for enterprises like say distribution, people that run distribution networks that basically move goods across different points. So they could use like blockchain technology to act as a single source of truth. Use blockchain technology as a single source of truth for multiple stakeholders in that network, so everybody can track the same thing from one source, and it helps to verify the integrity of data. So one use case is I think the one Walmart implemented a while ago. They implemented it for their own use internally. So they wanted to be able to verify where fresh produce, like the quality of fresh produce, starts depreciating in their supply chain. So they found out that there was actually a lot of discrepancies with like the data they were collecting across the network. So for instance, when a delivery service they use must have maybe delivered a batch of fresh fruits, for instance, to maybe the warehouse, there might be discrepancies in like the quality of the produce that was entered at that point versus the quality of produce when it left the farm. So they needed a system where all the stakeholders, the people they were buying from, the warehouse, the what's this thing called now? The dispatch guys could basically like update information about the goods they were transporting across the network, so they can easily track the point at which like maybe bad produce was delivered. So that's like a use case on supply chain. Then for benefits of smart contracts, so it's trustless and secure because of the reduction in intermediaries. There's a minimized fraud risk. So the reduction in intermediaries is basically like if you are going to execute a contract, for instance, a regular contract, you would require maybe uh, multiple human parties that would act as validators for the data. Now imagine if maybe you have a system where for every invoice that is issued out for delivery, it has to go through some sort of validation from an office or something. And the more human interactions you have in between this process, the higher the risk of somebody manipulating a particular record, or somebody buffing up the invoice. But with an automated and distributed and a trustless system, with a trustless and open system, you can reduce the amount of human interactions and intermediaries and also minimize fraud. And because this process is less manual and is automated, because this process is less manual and automated, it also reduces human error. And another benefit of the block of smart contracts is transparency. Because, like as I mentioned earlier, all actions are visible on the public block on all actions are visible on the public blockchain. So for blockchains like Ethereum, now the reason why it's public blockchain is actually mentioned explicitly is the fact that an organization, for instance, can decide to build an internal blockchain that's private just for their own use, and you cannot basically have access to that data as an outsider. Remember, the blockchain is just a technology. Anybody can adopt for their own use case. So for public blockchains like Ethereum, Polygon, Cosmos, Avalanche, all these public blockchains, all actions are visible and are queryable by anyone. Anyone can basically verify what action was carried out. Then let's look at challenges. Challenges with smart contracts. So because smart contracts are immutable, it means that any errors in code are permanent, and you have cases where bugs can lead to significant losses. I think there was a case of somebody that wrote a smart contract for a pre-sale smart contract and was sending the money for this pre-sale for the ICO for the initial coin offering, popularly known as like a pre-sale, to the smart contract itself, and did not add a function for withdrawing the crypto. So the person wrote a smart contract where like the user can say maybe exchange Ethereum for a certain number of their tokens. So after this exchange has happened and sales for the token has closed, person could not withdraw the Ethereum in the smart contract because the person forgot to add a function to withdraw the Ethereum. And if it was just maybe regular Web2 programming, it could just be deploy a new version of the API or something, and everything is normal, everything is fine. But because the smart contract is immutable, and because smart contract is immutable, the money that was sent to that contract was just lost forever. There was no way to retrieve it. Another challenge is the cost of gas. So when you're trying to make so this is like a problem that is multiple fold, and because we are talking about building front ends which are like user interfaces for smart contracts, I'm going to mention one of the sides of the problem, which is user experience. So say you onboard a new user, for instance, to your application. Let's say what application. Say you onboard a new user to your tab, for instance, and they're a first time crypto user. They've not used the blockchain or crypto for anything before. If they don't know that they need gas for transactions, it's usually a problem. First of all, educating the user, a non-crypto service user, that they need gas. They need gas for transactions, and it's also very difficult sometimes to get the gas they need for the transactions. So there are solutions that help to solve this problem. I think there was a recent AIP um, that proposed paymasters as a way for handling gas, which is like a good direction, step in the right direction. Well, the cost of gas is usually a bottleneck when you're considering your operational cost of maybe your DAP. Now, if you decide to want to cover gas for users, you're going to have to factor it into your operational costs. So it's either you're taking the risk of allowing users, assuming that your users know well enough to cover their gas by themselves, and risk losing users, or covering gas for your users and having to deal with the technicality of having to deal with that technicality, maybe in your running cost or something. So that's like one challenge with smart contracts, the cost of gas. Then scalability. So for some actions, for instance, it's usually very difficult to ensure that your contract executes sufficiently at scale. So now this problem limits the extent of what you can do with a smart contract. So for instance, say you're writing a smart contract for you want to put like um, you want to put you want to build something like something that allows maybe users create events on the blockchain, for instance, create events on the blockchain. There's a limit to the amount of data you can store on chain because storing data on the on chain is expensive, and doing maybe doing doing writes that involve bulk bulk data can be challenging. So one example is when you're trying to maybe update multiple records, for instance, in Solidity. We'd observe that you would have to look through each of these records to update them, to update them, and it adds to the size of your contract. So when you have like a contract that has maybe arrays or a lot of loops, for instance, you'll find out that the gas for those kind of transactions, depending on the amount of data you want to process, is actually going to be expensive. And if you're trying to optimize a contract like that, it's going to be very difficult because contracts are not exactly optimized for processing large things at once, especially Solidity contracts. So ensuring efficient execution for smart contracts at scale can be challenging. Okay, so let's look at working with smart contracts in Ethers.js. So the first action we are going to be looking at is smart contract, deploying a smart contract using the Ethers.js library. I'm sure maybe you've seen like you've seen how to deploy a smart contract maybe using Truffle, using Remix. So you can also do the same thing with in Ethers.js. And say maybe you're putting an application that requires a user to interact with maybe the DApp to deploy a contract. Here's how you can deploy a smart contract using Ethers.js. So the first thing we need to do is create a contract factory. Okay, go ahead, please.
Okay, yeah. So unlike okay, just like hard hat, right? Hard hat JS, we can also use Ethers JS to deploy contracts, right?
Yeah, you can use Ethers.js to create contracts, but you can't. Did you say create or compile? Sorry, let me make sure I heard you correctly.
I thought I heard you say that you can use Ethers JS to deploy contracts. So I was like,
Yes, you can use Ethers.js to deploy contracts. Yes.
okay, all right.
but not create contracts.
Create contrast. Can hard hats create contrast?
Hard is a tool for compiling and it's a tool for compiling and what's it called
Deploying.
Inter- deploying, yeah, and doing all the dev related stuff you need to do with your contract. But this is like on a user interface or on a front end. I don't know if that clarifies things.
What? Which one is on the user interface?
It has a jest.
Okay.
So sorry, somebody else has their hands up. Chidube, just go ahead.
Okay. I I want to know if there is a difference between Solidity, like using Remix for Solidity and Eta.js.
Okay, you want to know if there's a difference between using Solidity, sorry, using the Remix IDE
Yeah,
and it has JS.
yeah, yes, yes.
Okay, so were you in the previous class we had? That was on Tuesday.
No, I wasn't there.
Okay, so last week we started talking about how to build like a front end. Do you know what like front end is, right?
Yes,
Yeah. So how to build a front end that you can use to interact with your smart contracts that you've already created and deployed. So Ethers.js is a JavaScript library for that you can use in front-end applications where you have like buttons and inputs that the user can click these buttons to carry out a transaction or an action on the blockchain using your own user interface. Like you build out your own front end where you have maybe like a dashboard or a form that they can fill. And when they click on submit, it sends a transaction. So that's like what we're trying to do here. So the way it's different from um, Remix. Remix is an IDE for writing, testing, and deploying smart contracts. It is for this. It's for you to use as a developer, but ITAS is for you to use as a developer to build front ends that your user can use. Actually, baby, I don't know if that's clear.
yes, yes.
All right, Victor, please go ahead.
Is Ita.js like a library to connect your front end to your smart contracts?
Yes, it is.
Thank you.
Somebody else had their hands up. Previously. Something was that you? Okay, so yeah. So to deploy a smart contract, first thing we need to do is create a contract factory. And a contract factory instance can be created using the contract factory API. And the API expects the following argument: the API of the contract. And you can get the API after you must have compiled the contract. So whatever tool you use to compile the contract, either Truffle or Remix IDE or HardAct that has generated the API. So you need the API that was generated when the contract was compiled. Then second thing you need is the bytecode for the contract. So the bytecode is also generated when the contract is compiled, and it contains about information about the contract and the arguments that are needed to deploy the contract. Then you need a runner. So from the previous class we had, from the previous session we had, and from the recap we looked at earlier today, we mentioned a provider and a signer. So does anybody on the call not does is there anybody on the call that doesn't know what a provider or a signer is? Let me go over it again this last time.
Sorry, please. I don't know.
Yes,
I wasn't in
I
the
don't
last
know.
class.
Okay. So from the previous class we had, the provider is a read-only connection to the blockchain. Now, a provider is an object in ADAS or JS, and a provider is used to establish a read-only connection to the blockchain, and it allows querying the blockchain state, such as getting the account of the connected user, transaction details, querying event logs, or reading data from the blockchain. So, a signer is an object that wraps all the right operations on the blockchain. So in Ethers or GS, interactions with the blockchain are majorly divided into two: read operations, read interactions, and write interactions. Write interactions involve changing data on the blockchain or sending data to the blockchain, sending transactions to the blockchain. Read interactions involve reading data from the blockchain. Now, the difference between a provider and a signer, because both of them are runners, and by runner, they just mean like what will enable the contract to run. Both of them are runners in Ethers or JS. But the difference between a provider and a signer is that a provider can only read data from the blockchain, whereas a signer can authorize transactions. I don't know if am I do you have some sort of clarity or do I need to explain again? Is there anything unclear that I said now? Victor and Chipper.
Yeah, I understood.
Okay. The provider. Okay, I think we are like the provider. We developing the smart contract and connecting the client to the smart contract. We are like the provider, right?
No. So the provider is basically supposed to be exposed from the wallet you're using to connect. So the provider is just the connection. Ethers.js has their own abstraction for a provider, but when you're connecting a user's wallet to your tap, the user's wallet exposes a provider. So like I tried explaining, a provider is just something that establishes a connection between your dApp, your front end, and the blockchain.
Okay. Okay, I get it now.
Okay, Sumto, you have your hands up.
So does that mean that MetaMask is not like the only provider that can be used? I mean, can wallets in are wallets generally only providers that can be used?
So a provider doesn't exactly have to be a wallet. A provider doesn't have to be a wallet. Um, if you have like what's it called now? Let me see. How do I explain this? How do I explain this? How do I explain this? So the provider is what establishes the connection, but for a wallet to be functional, it has to be connected to a provider. I don't know if that makes any sense.
Yeah, yeah.
So for a wallet to be able to communicate to the blockchain at all, it has to be connected to a provider. And a provider would mostly so say we were going to want to instantiate a connection with an EVM, for instance, we can create the provider using the RPC endpoint and the chain ID for that network. Now using those details, using those details and a Web3 library, we can establish a connection that can basically read data, but we have not connected the user's wallet yet. But to be able to authorize transactions, you need a wallet to authorize the transactions. Can you, sorry, just go ahead.
Okay, one more thing. Can you just like explain this ABI stuff again, please?
Okay, ABI.
Yes.
Okay, so the ABI is like a data structure. It's a JSON representation of a smart contract that describes all the inputs, all the functions, all the events of the smart contract. That's what the API is.
Okay.
And it's mostly represented in JSON. If I go to Remix right now, let me see. Do I have if I go to Remix IDE right now, let me see. Let me create a mutable, vulnerable, possible. Okay, so um wait. So this is a contract, right? What's the problem? This is a contract. Now let me go ahead to compile the contract. Now you can see after compiling the contract, I have an API provided. I have an API here. Can you see the API? I can copy the API. So when I copy this API, I'm just going to paste it so you see the content of the API. Now this is the contract. Is my screen clear? Can you see my screen clearly? Okay. So
Yes,
let
it
me
is.
let me paste the content of the API somewhere. So you can see that the API is like a JSON representation of what I have in my smart contract code. Let's go over here. So remember that I imported ARC20, all these ARC20, blah 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 is imported here. So the API is going to contain all of the information concerning any imported contracts, the main contract itself. Let me try to find a function. Let me find a function so we can look at it together. So look at this input for instance. Look at this record in the API. This particular object in the API's JSON. So it's defining the inputs This object is for this function here, for the main function. It first of all defines the input. The first input is the address. The name of the input is store, as we have it here. The second input is amount. The type of the input is UINT256. The type of the first input, the internal type of the first input is address. If you check the name of the function, name of the function is mint. Function we have here. I don't know if that's clear now.
Yeah, it is clear. It is making sense.
Okay, okay, cool.
Yeah, it's very clear now.
Yeah. And also in Remix, let me see if I can use Remix to explain this provider thing. Uh, wow. So if I come to Remix and I try to select an environment. Are you familiar with Remix ID? Okay. So if I come to Remix and I try to select an environment, you can see the first thing it says here: injected provider, Coinbase. So which means that in this case, if I click on injected provider, it's going to ask me, okay, it's connected to my Coinbase, it's connected to my Coinbase wallet itself. So in this case, the wallet is the provider because it already has its own established connection to the blockchain. I don't know if that makes any sense. So a
Yes, yes,
provider
it does.
is anything that provides a connection to the blockchain.
Okay, please, can you like explain how providers work on their own, please?
How providers work on their own. So
Yeah, something like that.
when you create a connection, okay, sorry, from the regular English term, provider, and I said it provides a connection. A provider provides, right?
Yes, yes.
And what the provider provides in this case is a connection to the blockchain. And when you have established the connection to the blockchain, in the case of ethers, you can use that provider to reach the balance of a wallet, for instance. You can use that provider to get the latest block of the blockchain. You can use that provider to get the if there's a connected account to that provider. If your wallet is connected to that provider, you can use that provider to get the wallet address of the account that is connected, of the wallet that is connected. You can use the provider to get transactions. Yeah, sorry, Chidubem, just go ahead.
Okay, like if you're using MetaMask, will you use the injected provider, Coinbase?
So on this browser, for instance, I have both Coinbase and MetaMask installed. But for some reason on Remix, Coinbase takes precedence over MetaMask. Or I don't know, on Remix. It does that on some platforms. So if I do not have Coinbase installed, for instance, I should probably most likely see MetaMask here too. Sorry, Sonto.
Yeah, actually, what I was asking is, like the technology behind providers. Let's say you understand a bit how IPFS works, right? Are you getting? Do you get what I mean?
the technology behind providers.
Yeah, like
A,
technically,
a
just a
provider
brief
is
details.
a provider is just like a module that has been created. So let me show you. Were you in the last session?
Yes, I was.
Okay. So did you get to see when we established a connection to the blockchain using and created a provider from MetaMask? Just a provider from
Y-
MetaMask.
yes, I did.
So a provider is just like a module that has been written. It's a module that has been written.
Okay.
It could just be a JavaScript class, for instance, that has been written that has a specific set of functions that abstracts the actual interaction with the blockchain. So, for instance, now let me show you something. Um, Let me open this in Gitpod. Right. That's the code from last class. So in most cases, a provider just abstracts the connection to an RPC by providing utility functions that you can use to make requests to an RPC endpoint. So so for what we had here, for instance, we had a function somewhere. We had a function to we had a get balance function. Now under the layer, this get balance function communicates with the RPC endpoint. Under the layer, this get balance function communicates with the RPC endpoint. Let me see if I can find the RPC endpoint for querying balance on an EVM chain. So now, if you wanted to make that request yourself, for instance, yeah, if you wanted to make that request yourself, all you need is the RPC endpoint of a node that is connected to the blockchain. So this is quick node. Quick node is a node that is connected to the blockchain. They have a node that is connected to the Ethereum blockchain. So instead of coming here, instead of doing this as we have done here, doing provider dot get balance as we have done here, we can as well just use Axios or Fetch to make this API request and pass these parameters and still get the same result. I don't know if that makes any sense.
Yeah, yeah, yeah.
So the work of the provider is to abstract the connection to this RPC endpoint. To abstract the connection to whatever RPC endpoint your this thing you're connecting to as your node for the blockchain. Does that make sense?
Yeah, yeah. It is clearer now.
Okay. So you might want to take a look at the Ethereum JSON RPC API that basically lists out all the RPC functions. So this is like standardized across
Okay, I think Joshua left the call, probably his network. I'm going to send him a message, see if he can get back into the call. Right, guys, very sorry about that. I just spoke with him now, and he said he's trying to switch from MTN to another network. He would be back in shortly.
Can you guys hear me now?
Yeah, yeah, I can hear you.
Okay. So sorry about the interruption. I think that went off. So I think I was explaining what a provider really is and how it abstracts the connection to an RPC endpoint. So are we clear on that part on that conversation?
We ain't fully clear on it.
Yes, sir. Yes, sir.
Sorry, Victor, you were saying something.
I'm not fully clear on it, sir.
You're not fully clear.
Yes, sir.
Okay, so what part is confusing?
Can you do like a brief recap or something, please?
Can I do
A brief recap on it, please.
a brief recap? Okay, so on providers, I think you would actually understand better. Yeah, when you try your hands on stuff, I think you will actually understand better when you try your hands on stuff. So let me just try. Let me just go by one more time. So to establish a connection to a blockchain, yeah, you have modules that are written in form of libraries called providers, and a provider is like just like an SDK that helps you with interacting with the blockchain. That helps you with functions that you can use to functions that you can call instead of making API requests directly. So looking at the sample I shared earlier, example I was trying to show. Now, if you're going to make this API request, for instance, to get the balance of a particular address. Now, see how bulky the payload is. Let me see. Let me see something else. See how bulky the payload is. Like this is which the same thing you do in ethers when you have like a provider, just call the get balance function. But so I was saying that a provider abstracts making all these interactions with the blockchain with easy to call functions, like I was showing in the example we used in the last session, where we had this function. This is the same function to get. We are doing the same thing here. We are getting the user's balance. It's the same thing that is trying to happen here, where you have to provide the method, pass the params, specify the JSON RPC version. So it just makes like interacting with these functions listed out here, these JSON RPC functions listed out here, easier. Does that make any sense?
Yeah,
Hey
it
Flo.
does. Yeah, it
Okay.
does. I get it now.
So all right. So to create a token factory, I said you need to provide API, the bytecode, which I explained as it's a hash that basically represents the contract and the constructor arguments. Then a runner, either a provider or a signer. So this is what creating a token factory looks like in ADAS.js. So imported the contracts from somewhere, the bytecode from somewhere, and imported the contract factory API from ethers. And I'm creating a contract factory using a signer as my runner. Remember the arguments that it expects, the API, the bytecode, and a runner, which can be a provider or a signer. So in this case, I decided to use the signer because my intention is to deploy the contract, and deploying the contract will require sending a transaction, and I can't send a transaction with a provider. So I just decided to pass a signer straight ahead. But in cases where maybe you don't pass a signer straight ahead, you can you can connect the signer later in your code flow. You can use the connect function to connect the signer. But this is like the simplest way to create a factory with a runner. Do you understand what's going on in this code?
Sorry, does this mean that you are deploying the contracts from the front end this thing?
Yeah, basically, that's what I said. Yes,
Okay.
and deploying a smart contract from the front end. Yes.
Meaning there will be no need of using hard hats to do all the deployment and the rest.
No, you can. So that's the thing. Yeah, for cases where you need to do this, maybe you're building a front end that maybe requires deploying a contract when the user carries out an action. Maybe something like you're building something like Third Web, for instance, that provides you with a front end to create contracts. You can need this. But ideally, if you're building a front end, you probably would just deploy the contract yourself, maybe using either hard hat or something, and connect the front end of the contract using the contract address, the API. We'll see that later. But this is like you want to deploy the contract from the front end, you have a use case that requires deploying a contract from the front end. This is how you can do it in Ethers.js. Does that make any sense?
Yeah, it does.
Yeah, it does.
Okay. So after creating the factory, the contract factory, I'm then going to be deploying the contract using the deploy function. So a deployment transaction can be created using the deploy function on the contract instance. The contract instance, remember what we created, the contract factory we created. So any arguments that the contract constructor expects can be passed as arguments in the deploy function. So let me check. Let me check. Let me cross check with this guy. Where's that guy again? Let me. So for instance, our token contract requires needs an address, an initial owner argument. So if I want to deploy this contract from the front end, I'll be passing this address as one of the arguments here. Does that make any sense?
Yeah, it does.
Okay, cool. So after deploying the contract, we can get the transaction that deployed the contract using the deployment transaction function on the instance of the base contract that was created. So when you call the deploy function, a base contract is created. Oh yeah. Um, okay. After doing this, after deploying the contract, we're actually supposed to wait for deployment so that we can get this deployment transaction. So I think in the hands-on session, which like we should start very soon, it would actually take care of this use case. So I skipped a step here. Then interacting with smart contracts. So to interact with smart contract in Ethers.js, you need to create a contract object. So a contract object is like an object that represents a deployed smart contract and provides a simple JavaScript interface to call methods, send transactions, query logs, and listen for events. So a contract instance can be created using the base contract API, and the API expects the following arguments: a target, which is like the contract address of the deployed contract, the API of the contract, and a runner, like before, either a provider or a signer. So now, in the case of the contract instance, we can decide to use a provider if we only want to read data from the contract. But if we want to send transactions, we need to pass a signer to the contract. So we can either do that while we are creating the instance of the contract, or we can connect the signer later. So this example here adds the signer while we are while we are instantiating the contract. or maybe in your implementation, you want to maybe make some reads, you want to make some reads and only add a signer when connect the signer when you need to execute a write transaction. You can basically like do that. So does everybody understand what's going on here? Yeah, please go ahead.
Okay. From that contract address, is assigned an address. So I want to know, like, is it that address where it has to go to?
So the contract address is the address of your contract on the blockchain. So um, when you deploy, when you deploy your contract, when you get this deployment transaction, for instance, you can reach the contract address of the deployed contract and the events that were emitted from this transaction. So the contract address that is expected here is the address that was assigned to your contract when it was deployed.
Okay. Yeah.
Yeah. Are there any other questions from this part? Okay, so let's see if we can have the hands-on session in like 20 minutes. So oh, okay. So let's see if we can have the hands-on session in 20 minutes. So I think I would want something a simpler contract that I don't complicate things. Or do we just use this one? Okay, transfer. Okay. Let's use this contract. So I'm going to be deploying this contract on using it as on Polygon testnet. Do we do Polygon testnet or let me see. Hmm. Let me see if I have some if um Berlin. I'm not sure I do. Let's just use Polygon. Let's just use Polygon testnet. So from so if you still have the record from the last from the last session, if you have the record from the last session, so we're basically going to be doing we're going to be creating, let's create the components that are just houses like that would house our contract interaction. Hmm, let me just do it here. So we're going to have a button we're going to use to deploy we're going to use to deploy smart contracts. Let's create this outside the component. So deploy contract going to be async, going to await. Um so what arguments did we say we need to deploy a contract? Don't know if anybody remembers.
The ABI contract
Okay,
address.
we need the ABI, the what's
The
it called?
bytecode.
Yeah, bytes code.
Yeah,
We need the
bytecodes.
bytecode. Then what's the other one? Okay.
The provider. Yes,
Right.
we need the provider.
Okay. So we need a runner. So in our case, let's use a provider. Sorry, let's use a signer. Sorry, since we'll be needing to sign, we'll be needing to send transactions. So let's use a signer. Does that make any sense?
Yeah, it does.
Okay, so based on what we had from the slide, we're supposed to create a contract factory, right? Let's go ahead and create a contract factory. Yeah. Why are you duplicating this import? And that we need this ABI should not be a string actually. Let me see. ABI should okay, should not be a string though. Shouldn't be a string. Shouldn't be a string. Shouldn't be a string. Okay. Since don't worry. Let's do this instead. Let me create an ABI.ts file, then copy the API for that contract, for that token contract we had. Actually wanted a simpler contract. So let's use a simpler contract. Let's use a simpler contract. Okay. I think this one is simpler because it doesn't come with the baggage of all the doesn't come with the baggage of all the what's it called now? It doesn't come with the baggage of all that open Zeppelin library stuff. So just do something very simple. Let's see. Okay, so I'm just going to copy the API and put it here. Then the bytecode too.
Hello? Hello, I'm trying to reach Marcus Finley. Yeah, this is Marcus Finley. Who this? My name Bryce.
Okay, so let's import the API, contract API, the byte code, and it's a signer. So the next thing we're supposed to do is deploy, right? So our contract needs an argument. Our contract needs an argument. Sorry, let me wait though. Okay, I think we can add uh, an add type support for this guy. This is also satisfy the constraint any. Oh, no, 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 no. Wow. It's contract. This. Anyways, let's just move ahead. Oh, okay. So I said we are supposed to await the deployment before we can get to the payment transaction. So let me refer to the documentation and confirm that real quick. Wait for the financial. We use contracts relates to deployment. So we're supposed to wait for deployment. Process return. Oh, okay. I think this returns transaction. Let's see. Okay. So we can basically get the address of the deployed contract, or I want to get the want to just get the deployment transaction. Want to get the deployment transaction. So okay. Oh, nice. We need to wait for that. So the transaction is supposed to contain the contract address. Should I log this to console? So now that we have an implementation for our function, we can basically just we can basically just maybe put a UI on top of it and add like a button or something. Then I need to do one more thing. Is there anything confusing up to this point?
It isn't really confusing, but I think where the work is when we practice it ourselves. I'm using my phone currently, so I'm not following the codes.
Sorry, I did not hear that. What did you say?
Okay, I was like, it's looking good and not confusing. But where the work comes is when we code it ourselves. I'm using my phone. Not using my PC, so I'm not coding along.
Oh, okay. Why do you have to do this to me now? I'll just send this to you from my other wallet. Sorry, I'm trying to get testnet matic, so we can basically deploy this thing. Oh man. Okay, you know what? I'll do it on Polygon. I'll just do it on Polygon mainnet directly. Oh wait, come on. I'll just do this on Polygon mainnet. So let me grab this link. Go here. Go this here. Okay. Coinbase is doing this aggressive thing where it wants to force me to use Coinbase wallet when I don't want to. Let me see if that solves the problem. Yeah, does. Okay, so we're just gonna connect this guy. Yeah, so oh, the button is supposed to be somewhere. Hmm. Okay, so try to use this guy. Uh, Sorry, incorrect number of. Oh yeah, 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 yeah. Forgot something. So our contract expects one argument, which is like the number of decimals. The number of decimals. So I'm just going to use 18 since it's an ERC20 token. Just going to use 18 as the number of decimals. Right here. Oh, sorry. The initial supply. Sorry. Expect the initial supply. Yeah, initial supply. Sorry. So for that, I think we're going to be needing to we're going to be needing to That's the uh, what's this one? Say I want the total supply to be 500,000. 500,000 or 5 million. Yeah, I think that's 500k. So let's try calling the function again. Hmm. What happened? Invalid OP code. Wow. Wow. Bytecode I provided is valid now. So I think there's an issue with the bytecode that I provided, but it shouldn't be sure. Let me verify what the problem might be. Wow. So wow, this is interesting. Okay, so let me try. Saying I should compile my contract with a lesser version. So let me try that. That changed at all. Okay. Wow, surprisingly worked. So for some reason, compiling the contracts with um because I am on Polygon, I'm compiling the contract with a compiler that is greater than 0.8.2, 0.8.20 actually throws some OP code error. So you might not experience the issue if you're on maybe the Ethereum chain itself, or some reason I experienced that on Polygon. So you can see that my MetaMask is asking me to confirm a contract deployment transaction. Can you see the title of transaction here? Is everyone still on the call?
Yes, sir,
Yeah,
still on the call.
All right, cool. So I'm just going to go ahead and confirm this because I want that. So once the transaction is done, we should see the receipt or the transaction response log because I logged it. Okay, okay, great. So case response. So I am looking for the contract address should be here, shouldn't it? Access is generate the data from this guy Ash. That's a okay. Okay, so turns out um this guy this guy is not here. The okay, the contract address is not here, but I can get it from here. I can get it from this base contract with deployment. Because if I do this, if I say log base contract with deployment, sorry, the address. Eh, is it? Wait though. One of them has okay, oh there's a get address function here. Okay, yeah. So you can get the address of the deployed function here using the get address function. But then I copied the transaction hash, so I'm just going to go to Polygon scan and check the transaction so I can get the contract address. I don't have to spend gas to find the contract again. Yep. So this was the contract that was created. So it's a contract that we just deployed from the front end. So um after deploying the contract, let me see a function we can interact with. Wow. Let me see a function in the contract we can interact with. So I'm going to balance of messages sender. So since I basically own all of the total supply right now, I'm going to send some tokens. We're going to create a function that would transfer some tokens from my address to any address. So we're going to be interacting with this app with this transfer function here. Can we see that? We're going to be interacting with this transfer function here. So let's create a function on our front end to handle transfer. Same thing, we need the signer. Um, so we are going to create a contract instance. So we can use this contract. We can use either contract or base contract. I'm going to go ahead and use contract. So what did I say we needed to create a contract instance? Hello, can anyone hear me?
Okay.
Yeah, I said what did I say we needed to create a contract instance?
Contract address, ABI, and signer.
Contract address, API, and signer. Yeah, that's the contract address. Yeah, that's it. Come on now. What is it? Okay, so the contract address, the API. So the only new thing we're adding here is contract address. We already have the API and the and signer. So
Sorry, please, I have a question.
yeah.
Where did you get this bytecode from?
So when you I got it from I got it from Remix. When you compile your contract, depending on the tool you use, yeah, depending on the tool you use, it's part of the output of your contract compilation.
Okay,
But because
just
I
like doing get API.
yeah, exactly, yes.
Okay. Okay, so first I need to compile it in Remix, then
You
get
need to
the API.
compile it in Remix, yeah, or any other tool you're using, yes.
Okay, okay. Thank you.
Yeah. Wait though, I'm using the right contract instance. Why is this missing? Ah, Python. Sorry, let me confirm something. Sorry. Uh, Wait though. So we're supposed to call the method. So what's the function we want to interact with again?
Transfer token,
All right.
like to transfer, yeah.
Transfer, right? Um, according to our smart contract. So now the thing is, they should actually be like what's it called? If there's a way we can use our API and provide type support for this function, forgotten how to do this thing. We should be able to use our API to provide type support so that we can know what type of arguments that the function expects without having to go back to go and look at the smart contracts. I don't know if that makes any sense. Wait though. Oh, oh, wow, wow, wow. Okay. So, anyways, let's just go and look at the smart contract. The transfer function has expects an address, a destination address. It expects a value. So we're going to basically going to accept those as arguments in our function. Signer destination amount number. Um, yeah. So a destination and an amount. Now here's a problem. Yeah, just go ahead.
So I have a question to ask. Can you hear me?
Yeah, I can hear you.
Yeah, now to interact with a particular function from the smart contract, like from the front end, do we need to like use the ABI, the bytecode and the runner to interact with that particular function always?
Okay, so we needed the bytecode to deploy the contract. But so it depends on how you structure your application. Remember that this is just like this is just a technical session. So if I was basically building like an application where I know that okay, this contract instance is going to be reused in my application, I'm just going to abstract like creating an instance of the contract inside a module. So I only need to instantiate the contract once using the contract address, the contract API, the API. I don't know if you get. So if I do that now, if I do that, the only thing I will need to do is I'll connect the contract I've already instantiated with signer because you know that the signer is dependent on which wallet was connected to your application. You cannot determine the signer ahead of time. Signer is only determined when your user is connected to your tab. I don't know if that makes any sense.
No, not really. I don't really understand.
Okay, so for instance, now the first function we created was to deploy the contracts, right?
Yeah,
Yeah. So forget about this deploying contract function because let's just say you need to call this function just once within your application. But let's imagine that you have multiple functions that will be needing this contract that needs this contract that we've deployed already. Remember that this contract is we just deployed this contract now. Is that
yeah,
correct?
yes.
So I can create like I can create a module or something. I can create a module and abstract and take this guy out.
Okay.
That way you're only instantiating the contract once within your application.
Alright.
Now to use what I just created here, we're going to get an instance or get the contract instance. And because we need the contract to be connected to a signer, I can basically so here's what I was saying about being able to connect a signer to a contract. So I can basically connect the signer, can connect the signer, I can connect the signer and then use the contract. I use the contract with the connected signer to perform my read action. Does that make any sense now?
Yeah, 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 yeah. Those.
Okay, so let me confirm something from this guy's documentation. Turns a new instance with the same target for a different runner. Okay. Well, satisfactory. Okay, so let's use a base contract instead. It seems I'm doing something wrong. Seems I'm doing something wrong, but just wait a minute, let me figure out what exactly I'm doing wrong. Seems I'm doing something wrong actually. Let's see. Hmm. Let's see. Okay, so guess you could also do this. So we're sending with the destination and the amount. Yeah. So this will give us the receipts of the transaction. So let's just log the receipt also. So I'm just trying to create a form for what's it called, imputing the destination and the amount of token I want to send. So destination first, amount, then okay, yeah, sign up. Yeah, I think this should be it. Don't need this guy. Don't need this guy. So let's test that out. Okay. So someone should just drop your address or something.
Polygon,
Eh?
Polygon
Any
address.
yeah. So long as it's an EVM address, you can just connect to Polygon. Check.
Okay.
Yeah, is anybody dropping an address?
Yeah, yeah, I've dropped one.
Okay. So MetaMask is prompting me to hold up. Oh, so I made a mistake, yeah. So if you can see, I'm using the input that the user provided directly and see how much MetaMask said I want to send. Can you see it? Can you see the mistake?
Yeah.
So in my code, I'm supposed to convert the 500 to a big integer before before sending it in the transaction. So let me just do that now. I think we will do that somewhere, sir. Yeah. So I'm going to try transaction again. Then we'll see the amount at this page here. You can see it's 500 now, right?
Nice. Yeah.
Sorry, is anyone lost? I know we are tired, child. So this is like the last thing we're doing. So let's confirm this. Then let's see this. Whoa, 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 whoa. Oh, okay, okay. So here's the receipt for the transaction. You have the transaction hash here. You have other details of the transaction, like the gas price, the gas I spent, um, the block hash, and basic details about the. Okay, is there any events here? Okay, yeah, no, there's no event here. Okay, it is actually. You see events. But this is like what the receipt looks like. Can you see my console clearly?
Yeah.
All right. So let's verify the transaction on chain. So let me get the transaction hash. Um, yeah, this is the token we created. As the token we deployed from front end. Wow. Good though. What did I do? Set up supply. Wow. Anyways, so yeah, that's about it. So if you're interacting with any other contract that is not a token contract, it's actually still the same procedure. Create the contract instance with the contract address and the API. And if you're going to do something like this, then anytime you want to maybe read transactions, perform write transactions. That's transactions that anytime you want to perform transactions, you will need to connect the signer to the contract.
I guess why we had that huge supply because of the 10 raised power of 18 we had in the contract, right?
Yeah. So I forgot that ChatGPT is not serious. So in the code ChatGPT gave me, yeah, when I generated our contract ChatGPT, it was already doing the multiplication inside the contract. I don't know if you get. It was doing the multiplication inside the
Yeah.
contract. What I was supposed to do, I think what I was supposed to do was to send like 500 as 500 and not convert it to a bit int.
Okay.
So I think I'm just going to remove that in the code. This is it now. So I guess everyone is clear, right? Oh, so not very clear. So I think we're actually done.
I'm clear though. Thank you very
All right.
much.
All right. Darlington, are you still here?
Yeah, I'm actually here. I'm actually here.
All right.
It's been a long class. Thank you so much for the class, today, Joshua. I guess we'll be continuing or we'll be finishing up on Sunday, right?
Yeah.
Yeah, thank you so much, honestly. And Victor, I think you're the only one here currently. Thank you for staying till the end of the class too. I'm going to like make the recording available. So sorry I've not made the Tuesday recording available yet, right? So but I'm going to try to make all the recordings available by Sunday. I guess that'll be it. Good night everyone.
All right. Thank you very much. Good night.
Yeah. Nice.
Thank you, Joshua.